Hello everyone. Today we are going to explore about topic 2D translation in computer graphics. 2D translation, a fundamental operation in computer graphics, involves moving objects or points within a two-dimensional plane. It's a core concept used in various graphical applications, including animation, game development, and user interface design. Understanding 2D translation is crucial for effectively manipulating and positioning objects in virtual environment. Understanding the translation process. Initial coordinates. The initial position of an object is represented by its coordinates x-hold and y-hold. In the 2D plane, this defines the object's location before any translation in applied. Translation vector. We have to define a vector. The translation vector Tx and Ty determines the magnitude and direction of the movement. Tx specifies the horizontal shift and Ty represents the vertical shift. A positive Tx moves the object to the right and negative Tx moves it to the left. Similarly, a positive Ty moves the object upwards and negative Ty moves the downwards. New coordinates. New coordinates x new and x y new of the object after translation are calculated by adding translation vector of the initial coordinates. X new is equal to x world plus tx, that is translation vector, and y new is equal to y world plus ty. This results in object being moved to its final position in 2D plane. Visualizing 2D translation. Movement. Imagine a simple shape like a square or triangle or 2D plane. When you apply translation vector, the shape moves along the plane, following the direction and magnitude defined by the vector. Coordinate system. The translation process is based on coordinate system, usually with x and y axis. The coordinates of the object represent its relative position to the origin of the coordinate system. Transformation. Transformation is the considered a geometric transformation, which means it changes the object's position without affecting the shape or size. The object orientation remains unchanged. Translation in matrix form. In this, we are using x new is equal to x world plus tx and y new is equal to y world plus ty. The translation equation can be represented in more concise and efficient way using matrix multiplication. By introducing the third coordinate, one called the homogeneous coordinate, we can represent 2D points as 3D vector x, y, and 1. This allows us to express the translation as a 3 by 3 matrix multiplication, providing the convenient way to handle multiple transformations in sequence. Practical applications of 2D translation. We have many applications of 2D translation. In this, we mainly use it in animation. 2D animation translation fundamental for creating smooth and dynamic movements by applying a series translation over time. Animators can bring character and object to life, creating realistic and stylized movements. Think of character we can across scenes or car driving down a road. Game development. Game developers utilize 2D translation to move game elements such as player, character, enemies, and objects. This allows for interactive gameplay where players can control characters and interact with the game world. User interface design. User interface often employ 2D translation to position and move interactive elements like buttons, sliders, and menus. The ensures that users can easily interact with the interface by dragging, clicking, or selecting elements. Understanding the homogeneous coordinates. Simplifying transformation. The homogeneous coordinates enables a unified approach to representing points and vectors in 2D. This allows us to perform all geometric transformation, translation, scaling, rotation, using metric multiplication, simplifying the overall processes, extracting to 3D. The concept of homogeneous coordinates extends naturally to 3D graphics. In 3D, we are introducing fourth coordinate W to represent points and vectors, and making it possible to perform 3D transformation using matrices. This is powerful technique for handling complex transformations into 3D space. Enhanced flexibility. The homogeneous coordinate system provides increased flexibility in handling various geometric transformations. It allows us to combine different transformations into a single matrix operation, making it easier to perform and complex transformations in single step. Combining translations, concatenation, order of operations, and efficiency. Multiple translations can be combined by multiplying their corresponding matrices together. This creates a single matrix that represents overall transformations resulting from the sequence of translations. Order of operations. The order of matrix multiplication matrices performing the translations is different orders will be lead to different final position. The matrix multiplication orders determines the order in which translation are applied. For example, multiplying T2 by T1 will result in applying T2 first and then T1. Efficiency. By combining translation into a single matrix, we can apply all the transformations simultaneously. This significantly improves efficiency, especially when dealing with complex graphic senses involving multiple transformations. Finally, we are coming to conclusion. Understanding 2D translation is essential for any professional working with computer graphics. It provides a fundamental tool for positioning, moving, and animating objects in 2D environment. By mastering the concept of translation vector, matrix representation, and homogeneous coordinates, you can efficiently manipulate objects and create compelling graphics experience.